The figures on the slide illustrate the basic experimental situation for using the t-test statistic or the z-test statistic. It is assumed that the parameter mu is known for the population before treatment. The purpose of the experiment is to determine whether the treatment has an effect. We ask, is the population mean after treatment the same as or different from the mean before treatment? A sample is selected from the treated population to help answer this question. In the hypothesis testing situation, we begin with a treated population with an unknown mean and an unknown variance. The goal is to use a sample from the treated population, a treated sample, as the basis for determining whether the treatment has any effect. As always, the null hypothesis states that the treatment has no effect. Specifically, the null hypothesis states that the treated population mean is unchanged. Thus, the null hypothesis provides a specific value for the unknown population mean. The sample data provide a value for the sample mean. Finally, the variance and the estimated standard error are computed from the sample data. As with the z-score formula, the t-statistic forms a ratio. When the obtained difference between the data and the hypothesis in the numerator is much greater than the expected denominator, we will obtain a larger value for t, either large positive or large negative. In this case, we conclude that the data are not consistent with the hypothesis, and our decision is to reject the null hypothesis. On the other hand, when the difference between the data and the hypothesis is small relative to the standard error, we will obtain a t-statistic near zero, and our decision will be to fail to reject the null hypothesis.